Have you ever wondered how a few simple lines of text can turn into a killer app on your phone? You know, one that can navigate a new city for you or connect you with friends halfway across the world? Well, it's not magic. It's actually all about three fundamental superpowers in coding. Today, we're going to unpack the logic that literally breathes life and intelligence into a program. So yeah, how do we make that incredible leap? How do you go from a basic, boring checklist to a dynamic app that can react, adapt, and do its job perfectly, maybe millions of times over? That's the big question, right? And we're going to answer it. I want you to think of your code like an assistant, a very, very literal assistant. Right now, all it can do is follow a simple to-do list, step by step. Kind of boring. Our goal is to give this assistant a serious upgrade, to turn it into a smart, responsive partner that can actually make its own decisions. And we're going to do that by giving it three distinct superpowers. Okay, first up, the ability to choose. This is where we teach our assistant to stop just blindly following a list and start making some intelligent decisions for itself. This is the superpower of branches. So what in the world are branches? Well, think of them as forks in the road for your code. Based on a simple true or false question, the program decides which path to go down. It's honestly as intuitive as you looking out the window in the morning. Is it raining? True. Okay, grab an umbrella. False? Grab sunglasses. It's just that. And this logic follows a really clear path. The program asks itself a question, starting with if. If this thing is true, do this. If the answer is no, it moves on to elif, which is just a nerdy shortened way of saying else if, and it checks another condition. And if all of those checks fail, it has a default plan, a fallback under else. This simple structure means your program always knows what to do, no panicking. And here's what that looks like in actual code. See? The program is checking a person's age. If the age is 17, it prints one thing. Else if the age is 18, it prints something else. And for any other value, it just says there was an error. That's our assistant in action. It's handling different situations with total precision. And that flexibility right there is what makes code so incredibly powerful. Okay, so our assistant can now make smart decisions. That's awesome. But what about those really tedious, repetitive tasks? We don't want it to get bored or, quit. That's where our second superpower smashes onto the scene, automation. And it's all powered by loops. Loops are the absolute engine of efficiency in programming. I mean, instead of writing the same line of code 1,000 times, you just write it once, pop it inside a loop, and tell the computer how many times to run it. This one idea saves an unbelievable amount of time, it prevents silly mistakes, and it lets your programs work on a massive scale. Now, you're mostly going to run into two main types or flavors of loops. First, you've got a for loop. This is for when you know exactly how many times you need to do something. Think, polish all 10 spoons in this drawer. Then you have a while loop. This one keeps going as long as a certain condition is true. Think, stir this sauce until it's thick. See the difference? Both automate, they just give you different kinds of control. Now take a look at this while loop. Its job is to count all the way to 10,000, but I want you to notice that tiny little crucial line at the end, count plus equals 1. If you forget that line, the count never changes, the condition is always true, and your program gets stuck counting forever. And my friend, that is the dreaded infinite loop. It's a rite of passage for every single new programmer. You'll make this mistake, I promise. All right, our assistant is smart and it's super efficient. But as our programs get bigger and more complex, things can get, messy. We need to stay organized. And that brings us to our third and final superpower, building reusable tools with functions. This toolbox analogy is just perfect. Think of functions as custom tools that you build and put in your programming toolbox. Instead of rewriting the same block of code every time you need it, you just package it up neatly into a function. Then, whenever you need that specific job done, you just reach into your toolbox and call on the right tool. Simple. And putting one of these tools to work is a really simple three-step process. First, you define it. You basically build the tool and tell it what it's supposed to do. Second, you specify its arguments. These are the materials it needs to work with. Like if it's an add function, it needs 2 numbers. And finally, you call the function, which is just you telling the program, hey, pick up that tool and use it right now. Okay, here's a quick but really important distinction. You'll hear these 2 words. A function does a task and then returns a value back to you. It gives you something back. Think of asking a calculator, what's 2 plus 2? And it gives you back the number 4. A procedure, on the other hand, just does something, like printing a message on the screen, without giving anything back. The whole key difference is that return value. So, there we have it. We've equipped our little assistant with 3 incredible superpowers. Now let's just take a step back and see how all these amazing tools fit together in our complete programming toolkit. Here it is, your complete toolkit, your cheat sheet. We've got branches for all our decision-making. We've got loops for automating everything. And we have functions to keep it all organized and reusable. It's the combination of these 3 simple ideas that lets us build programs with mind-blowing complexity and power. And honestly, this right here is what it all boils down to. Whether you're looking at a tiny script or a massive video game, I guarantee you will find these 3 structures at its very core: branches, loops, and functions. They are the absolute fundamental building blocks, and they work together to bring every single piece of software to life. So we've opened the toolbox. We've looked at the core tools of creation. Mastering these is the key to building pretty much anything you can imagine. So really, there's only one question left to ask. What will you build?